Okay, gang, we're going to continue working through this problem set on limits. And we've done the first few problems here. I think we're down to letter E. And it looks intimidating. It says the limit as x approaches e of the natural log of x over 2. Hey, when in doubt, we just plug it in, right? We just go ahead and try to evaluate the limit. So we got the natural log of e over 2. And guess what? Even if you forgot about e and natural logs, you could jam it in your calculator. The natural log of e just happens to be 1. I get a half. And why did it work out? Because natural log of x is a continuous function. And in particular at e, it's just a continuous smooth curve, no problem. You could plug it right in. So as intimidating as that looked, it was a pretty easy problem. Now the natural log of 0, you cannot plug in 0, right? The natural log of 0 is undefined. So if I'm looking at f, I can't plug it in. But guess what? There's this little plus sign. That means, of course, the right-hand limit or just to the right of 0. So numbers that are just barely positive, which you can take the log of positive numbers. So in this case, I'm going to take a quick look at the graph here. I'm going to sketch it. Don't forget, natural logs have a vertical asymptote, or any log has a vertical asymptote at 0, and then they just kind of slowly meander up here. Of course, they all hit the point 1, 0, unless there's any shifting. But that's kind of, that's the graph here. So what are we going to do? We're going to let x get close to 0 from the right side, and I guess I'll color code this, right? So as I'm cruising in towards x equals 0, what's happening to the y values? It's pretty obvious. I'm going through the basement here, right? So where am I heading? I'm heading downstairs towards negative infinity. Don't forget, limits are y values. We're looking at the y values as x gets close to 0, negative infinity. Easy peasy, nice and easy. So, there's a lot of ways to do these. You can do problems algebraically like we did earlier in the page. You can always just kind of graph them and just figure out what's going on from the graph, right? All right. Now here's a piecewise function. And, again, they look intimidating till you understand what the symbols actually mean. X less than -1, that means left of -1. I'm sorry, left of 1, right? And this x greater than 1, what is, can't believe I did that. What does greater than 1 mean? It means to the right of 1. Left of 1 is like 0.9 and 0.99 and 0.95. Right of 1 is 1.01 and 1.001. Numbers just above 1. Okay, so this one is a graph. There's the graph, okay? And let's look at A, B, and C. A, B, and C look at 1, right? Well, wait a minute. Oh, I'm sorry. the graph is for another problem. Ignore what I just said. So ignore that graph below. Number 2 there, it's not graph, but that's okay. So I want to look at 1 from the left. So for number A, right, I'm only concerned with this top part of this function because I want 1 minus, that means the left side of 1. So let's plug in 1. I get 1 squared minus 3 times 1. Right, 1 squared minus 3 times 1, that gives me -2. So again, easy math, no problem. It's all in the symbols. Now, part B says 1 plus, that means the right side of 1, right? That's what that little superscript means. So I'm plugging into that, right? I'm plugging in log, still plugging in 1. I got 1 plus 9, so that's the log of 10. And the log of 10 is just 1. And if you forgot that, jam it in your calculator. Don't forget, log has a little 10 down here. So 10 to the first power equals 10. And then finally, part C says, hey, what's the limit? Well, you got to look at the left-hand limit and the right-hand limit. Well, the left-hand limit's -2, the right-hand limit's 1. So guess what? The limit does not exist, right? The left-hand limit has to equal the right-hand limit. All right, let's keep going. D, E, and F. D says G of 1. Well, the question is, do we plug into the top or the bottom? Well, we plug it in the top because it's greater than or equal to. So g of 1, you know, it's just 1 squared minus 3 times 1. We just saw that. That's negative 2. Right? Means what's the y value when it actually goes 1? E says the limit at negative infinity. Well, negative infinity is left of 1. It's less than 1, so it's left of 1. So we look up top, right? So up top, what do we got? Negative infinity squared minus 3 times negative infinity. Well, negative infinity squared, that's positive infinity. 2 negatives give you a positive. And 3 times negative infinity, that gives you positive. So what, I mean, this sounds silly, but what happens when you take an infinity and add 3 infinities? You get more into infinity, right? I mean, you get an even bigger infinity, which is just infinity. And finally, what's g of positive infinity? Well, now that's right of 1, so that's the bottom. So you're going to take the log of infinity plus 9, which is the log of infinity. Now, a logarithm, I guess I got a graph real quick just to remind you what the graph of a logarithm looks. It looks like this. It slowly meanders up. So as you go to the right, it'll take a while, but guess what? You'll keep going up towards positive infinity. So that's also infinity. So I'm going to stop it here. We'll do one more video to get through this worksheet, but hopefully that was helpful for you.